Hello, this is question 9 on your mixed exercise 14. So the price of a computer system can be modeled by this formula, which is an exponential with a negative exponent, which means it's decreasing with time, which is what happens with the computers really. So where P is the price of the system in pounds, and T is the age of the computer in years after being purchased. Calculate the new price of the system, which means the price when the system was new. Yeah, so I think it's strangely phrased. So when the system is new, T is 0, we are going to substitute T by 0 in the model. So 100 plus 850 e to the power of 0. E to the power of 0 is 1, so this is 950 pounds. Yeah, that's the price when it's new. B, calculate the price after 3 years. So now B, T is going to be 3 years. So again, we substitute. So this is going to be 100 plus 850 e to the power of minus 3 halves. And this is 289.66 pounds. It doesn't say to the nearest pound. When we are modeling, we can just round to something easy. So 290 pounds, yeah? 2, 3 significant figures. C, when will it be worth less than 200 pounds? So what we are going to check is when is 200 pounds. So how many years need to pass until the price is 200, and then after that it will be less than 200. So we substitute the price by 200 and find T. We are going to put all the numbers together. So 200 minus 100 is 100, is 850 e to the power of minus 3 halves. We can divide, and we have 10 divided by 85 is e to the power of minus 3 halves. And that means that taking ln, so I have ln 10 over 85 is going to be minus t halves. So t is going to be minus 2 times ln of 10 over 85. And this is 4.28. This is years. So that means that after 4.28 years, the computer will be less than 200 pounds. D, find its price when t increases to infinite. Yeah, so when t tends to infinite. When t tends to infinite, this is going to be, let me show you, easier if we write with the e in the denominators. So the price is going to be 100 plus 850, 1 over e t halves. I think this is easier to see. Yeah. So when t tends to infinite, this tends to infinite, which means 1 over something tending to infinite is going to be smaller and smaller and smaller. Yeah, this is going to tend to 0. So the whole thing is going to tend to 100. Yeah. So when t tends to infinite, e to the power of t half is going to tend to infinite, which means 1 over e to the power of t half is going to tend to 0, which means p is going to tend to 100. Yeah, and well, I'm going to write the pounds. 100 pounds. Then sketch the graph of showing p against t. So p against t, p in the vertical axis, t in the horizontal axis. It doesn't make sense to have negative time, so I'm not going to represent anything on the left. Yeah, and the initial value was 950, and then it's going to decrease. So it's going to do something like this. And we have to think where our asymptote is, yeah? Because if a normal exponential will have the asymptote here, but we are adding 100 to a normal exponential, if you want to call this a normal exponential. If we add 100, that means we are translating everything up, included the asymptote. So the asymptote is going to be in the 100. So p equal 100. It's not going to be really in the 0. but in the 100. Yeah, and you can see this with this thought, this thinking that we did before. Yeah, when t tends to infinite, when t increases and increases and increases, p tends to 100, not 0. So this is my asymptote. Then comment on the appropriateness of the model. So I think it makes sense that always when you sell the computer, it's going to have at least a minimum value, although that's not always true, I would say. But the £100 would be the minimum value of the computer. Sometimes you only can recycle them. Would be the minimum value of the computer. Value of the computer. Or this, it's not a computer, no? It's a computer system. Well, computer. And that's all with this question.